can see me there in the left top corner, in front of a big sea fastening construction. And I started as an engineer at TWD. So how does the work week of a typical project or an engineer looks like with us? Of course, you have a lot of contact with the client because we work for clients. We want to help them accomplish their goals, so we help them as good as possible. So we have a lot of contact, we have a lot of questions. The biggest question is always, what does the client really want? So sometimes the client says, I want a lifting tool or a monopile. I'll come back to that later. But then actually what he actually wants is he wants to lift a monopile. So don't jump into conclusions or solutions, but always think about what they really want. We do a lot of brainstorming. We develop concepts, which you can see in the sketches on the right side. So we make sketches of concepts, and we materialize that with the tools that we have at hand. So for instance, Excel tools, hand calculations, but also more complex chem calculations. Finally, we don't weld it all together, but we do check on the fabricators that fabricate our designs. And my group where I'm working in is really focused on that. So what we do is we check if everything is built to our specifications, and also with the right certificates and the right traceability. So that also means going to the location and checking on if everything is according to the drawings. TWD itself, the company, is built up of multiple nationalities. The most common study is mechanical engineering, but we also have a lot of civil engineering and even some architects in the office. The most common function is engineers. We have a lot of different nationalities, like I said, and what's also funny is the average age, which is approximately 30. Me, myself, I'm 35, but I'm already one of the older ones here. So that's really nice, so that you have a young atmosphere and a lot of good innovative ideas. And we're located in Rotterdam. We also have an office in London. We have one office in Greece. The majority of the people work at Rotterdam. The people, there are also some people working from London and from Greece. There is also some exchange possible in between the different offices. Like I said, we have a relatively young company, so we also have a lot of fun activities. On the left top, for instance, you can see the ladies' night, because the structural engineering is still dominated by men, of course, but I can also see some ladies in the group here. We also have a lot of female employees, so they try to bond sometimes, but also we have some group activities, company trip every year. On the top right, you can see the Dress Like a Boss Day. That was for the boss's birthday. We all dressed up like him. Normally, everybody is more dressed in their casual clothing. But also some sport activities, the harbor run, and some festivities, and even some expos that we go to with our different employees. The markets where we are active in, mainly on offshore wind. Then we have the offshore civils as well, for instance, bridges. And then you need to think about that. We're not designing the bridge itself, but we're designing the tools to install the bridge. Oil and gas, salvage, which you can see on the bottom left. So retrieving wreckages from the seabed, decommissioning of oil platforms, and on the bottom right we have the motion compensation systems that we also developed for our sister company, Bargemaster. The offshore wind is the biggest branch that we're in. We have a large track record for that. So all the wind parks on the North Sea, we contributed more than 80% of them with our tools and with our installation and so for instance, what did we do on one of these wind parks for our client GOC? We designed some sea fastening monopiles, which you can see on the deck. We also designed the gripper for the installation of monopiles. You can imagine that a wind turbine is built up on offshore by drilling that big monopile, which is on the middle of the vessel, into the seabed, and then they place the yellow colored TP, which you can also see on the vessel, on top of it, and then on top of that one, the complete wind turbine will be built. So these monopiles can weigh up to 1,500 tons. So what we designed for them was sea fastening. So make sure that everything is nicely placed on the deck without puncturing to the deck. So make sure that the vessel is strong enough to carry the monopiles, also the TPs. Also, you can see that the monopiles are laying down now, and these monopiles need to be upended. So they need to go from horizontal to vertical. So we also developed the upending bucket for our client. And finally, to install the monopile, it has to be kept solid, straight on the seabed for hammering. And you can imagine that waves and current can all flow against the monopile and can make the monopile move and make it go out of tolerance. So we built a gripper, which is on the side of the vessel, which holds the monopile in place while hammering it into the seabed. So you can see the gripper more closely here. A monopile is just hammered through the gripper. So the gripper is hanging on the side of the vessel, and they can move it back into the vessel. And of course, we always try to minimize the weight and maximize the stiffness to increase the efficiency, but also to decrease the cost of these items. Usually these items are built for project base, so they use them for one project, for one wind farm, and after that they are scrapped because the next wind farm usually uses different monopiles. So we also made this one versatile so that they can also use it for multiple projects. And also the sea fastening is intended to be used on multiple projects. You can see one of the monopiles here, which is installed. So the sea fastening of the monopiles was built on these cradles. The cradles hold the monopile in place during the sea voyage. So when the vessel is moving, the monopiles are kept in place on the vessel. It can be used for different diameters, and it can skid towards the crane. So it can move towards the crane with the help of the yellow hydraulic cylinders that you can see. And that's to get the heavier piles in the crane range, so that the crane can still pick them up. So you actually move the load a little bit closer to the crane, so it's easier for the crane to pick up the loads. You can see the upending bucket next to it. See if I have for everyone. This is the upending bucket, and that keeps the tail of the monopile stable while it's upended. So when it's brought from horizontal to vertical, and that's to increase the safety, of course, because you don't want the 1,500 tons monopile swinging over the deck while you're installing it. The yellow TPs that you saw, the vertical columns that were on the deck, we also need to sea fasten them. You really need to secure that to the deck, because you can imagine that it's really unstable when the vessel is sailing, that the TP, if you place it loosely on the deck, then it can easily topple over. So we made a system so that they can easily, by hand, fasten the TP on the transition piece on the vessel, and that also increases the speed of fastening it and loosening it instead of using bolts or something like that. So we developed some clamps that they can easily apply. This is the part of this project. This project was for the installation of wind turbines with monopiles and transition pieces. However, sometimes these windmills are built up of jackets, which you can see here. This is also on the North Sea. So the yellow part that you can see here is a big jacket that is built by a company. And for installing it, they need a lifting tool. So they need something in the crane that grabs the big jacket. It weighs 1,600 tons, and that they can install it offshore so that they can lift it from the vessel onto the seabed. So we developed a lifting tool for them, which is the orange part that you can see there, with the blue part, which is on top of the jacket. You can see the crane hook on the top and some big lifting slings. So that's one of the things that we also delivered as a complete package. So next to the design, we also had it built by one of our partners, and we delivered this item turnkey to our client Van Oort. So here you can see the full picture. The vessel, the Boca Lift 1, has two jackets on top on the deck. And if you look closely, you can see in between the crane hook and the jacket, there's our lifting tool. It hooks underneath the flange of that jacket to pick it up and to install it. And here you can see two pictures. On the left, it's also used for a jacket, and on the right, it's also used for a monopile. So with some small adjustments, we can modify the existing tool to fit different items, so they can also use it to install different items. This is also used for multiple projects, which of course also increases the efficiency of the tool and the design that we delivered for them. The thing is fully remote controlled, so nobody has to go up there to install it. They can just lift it in with the crane, activate it. It will lift up the jacket, install it on the seabed. Then they can deactivate the lifting tool and get it back on deck. This is a project that took us approximately 2 years of engineering, and that starts off with a concept, so with brainstorms, concept meetings with the client as well, but also with everybody giving their input and giving their ideas. And then in the end, a complete tool is delivered, which is also, of course, a very satisfying. This is another monopile project that we did for our client. Here you can also see some monopiles that are installed on the deck, that they're laying on the deck, and they're sea fastened. Some of the sea fastenings are seen here, as well as some precision piece sea fastenings. So we used a different concept of our clamp that we saw in the previous project. And that's also one thing that I wanted to show with these slides, is that although a lot of solutions always look the same, there are often some subtle changes that makes the design different. So we also always have to start from the beginning again. Of course, we can get some inspiration from the previous designs that we deliver, but we also have to make some new designs. So for instance, one of the requirements of the transition pieces in this project was that they have to be elevated, so they have to be higher on the deck than the previous ones that we saw. So that's why we also designed some different constructions for this one. And also the clamp design itself was different due to space restrictions. Here you can see an upending bucket that was also delivered. You can see we also had an upending bucket on the previous project with the green upending bucket, but you can see that this is a different one. That was also because the monopiles were placed transversely on the previous deck, and for this one they are placed in longitudinal direction of the deck. And this thing can also skid too, so you can see that it's placed on a big rail, which it can move over. But I have a movie later on which will show this nicely. So this was these items were used by our client Van Oort to install the monopiles. Again, they also needed the gripper to keep the monopile in place on the seabed during the current and the wave loads. So we also built a versatile gripper for them, which they can use for multiple projects. And you can see that hanging on the side of the vessel there. The vessel itself is a jack-up vessel. Most of the installation works are done with jack-up vessels at this time. So it's a vessel that can lift itself with the legs out of the water to provide a stable base for the installation of these monopiles. And in the back of that picture, you can see an installed monopile with a TP on top, which is placed on the monopile. So this gripper was also made for the client. It was fully designed, and we also did. We didn't deliver it turnkey, but the client decided to have it built himself. But we did provide some engineering services during the build. You can imagine that, of course, there are always some unforeseen items or some input from the fabricator that says, "Oh, I think maybe if we reduce some welds or increase some plate sizes, it will be easier to fabricate." And then we can advise on that. We can help them during the build. Some other things is because we're fully focused on the design, we know this thing from inside and out. We can easily check up on some things, some issues that we see during the fabrication. I will never forget that I was at one of these builds once, and then they were fitting up something, and then I took a designer with me, a draftsman, and he immediately said, "Well, they are fitting it up on the wrong side." He immediately saw it because he was fully seeing that design on his computer screen every day. So he spent a lot of time with it, so he immediately saw it. We told the guys, and they can easily put it on the other side, and it saved them a lot of hassle if they already welded everything completely. So we can really be of added value during the fabrication of these things as well. You can see a movie of how an installation of what I just discussed is going like. So the gripper is placed, moved outside to the vessel. It can fold down, and that's to make it easier during transport. For instance, if you had to go to cross bridges or put it next to the vessel. Then the crane can grab one of the monopiles. It grabs it at the top with a lifting tool, not our lifting tool, but okay, and it gets upended, so it gets into vertical position. You can see on the tailing side of the monopile that the upending bucket that we designed is controlling the upending, so it makes sure that the tail of the monopile is not moving over the deck. And it also doesn't bend, so that the structural integrity is okay. Then the monopile is placed in the gripper. And supported by the seabed, the prepared seabed. The gripper can be closed, and then it wasn't really the design thought, but I heard from one of the operators they could still adjust the position of the monopile a little bit with our tool, so they can manipulate it a little bit so that it's in the right inclination, in the right position. Then the hammer is placed upon the monopile. For this project, they used a big yellow hydro hammer, and the monopile is hammered into the seabed. And the gripper could open to make room for the hammer to file the monopile completely through the gripper and deep enough according to the specification. Well, after that, they can fold the gripper back to the deck, and they can even slide it a little bit inwards, so that the vessel, when it's back to the quay side, it can move again back in. And one other thing is that during voyage you don't want anything sticking out of the vessel that much, because it can also slow down your vessel. So you can see here that we work mainly with jack vessels. So those are the vessels that jack themselves out of the water. But if we want to go to deeper water and also with heavier turbines, these vessels, they get up to their limitations. So the newest vessels that are built at this point are floating vessels, which you can see some image of that, some artist impression of that over here. But you can imagine if you have a floating vessel and you have a gripper attached to that vessel, then the complete vessel and the gripper will move. So it's really hard to get that monopile in tolerance within in the seabed. So that's why we're now developing the motion compensated gripper. Maybe some of you guys heard of the Ampelman, but I will also get to some other motion compensation systems later on. So while the vessel is moving, it keeps the gripper exactly in place up to the coordinates, and you can use that gripper to install the monopile. And we do that by using different actuators, so hydraulic cylinders and hydraulic systems with some control software to keep that monopile in the same location. And it's a tailor-made integral solution for upending, lowering, and pilot. So a client comes to us and he says, well, I want to install monopiles and I don't know how to do it. So then we can help them with the complete layout of their vessel. Motion compensation systems, I already talked to it a little bit. This is an example of a motion compensation system that we designed for our client Bargemaster, which is also our sister company. It's the Bargemaster T700. It can be used as a platform on a vessel. So as I said, when the vessel is moving, the platform keeps exactly steady. And we can place a crane or some cargo or a drill or something like that. Anything you want to be compensated on that platform, up to 700 tons. It was firstly used for installing of a bridge in between two oil platforms. To keep that thing stable while it's being lifted off by a crane. This is a picture during the test phase where they also lifted off a load, for instance, next to a jackup vessel, so they can easily use it to safely transfer loads from a fixed platform from a barge to a fixed platform, and vice versa. Here's a small movie of the system. So you can see that if you're standing next to it, it looks like a rodeo. But when it's doing its job during movements, it really works very well. So you can see over here, you can see that it stays exactly at the same level as the horizon, while the vessel where it's standing on is moving. In this project, they used it for drilling. So to drill something in the seabed. It showed some real potential there because it can keep the drill exactly on the right position, because you don't want any hammering of the drill on the seabed. And this was a project that we conducted in the North Sea. So our sister company Bargemaster, they're performing this project, and we provide them with the tools to do that. We did a similar project like this last year in the Caribbean, which is a bit more nicer weather. And also me and some colleagues went over there to help the guys from Bargemaster out with the operations of this thing. Next to that platform, we also built a crane for Bargemaster. That's the same idea. So while the vessel is moving, the crane keeps steady on the same location, which you can see really clear in this movie. And for offshore operators, that's of course very nice because that gives them a lot of control while they're working offshore. So especially if they're servicing fixed platforms, so maybe oil or gas platforms, but also wind turbines, this system can really help them out with the increasing the safety and the workability. Next to this crane, they also developed a walking platform, so a gangway. You might be familiar with the Ampelman, which is also a similar type of system. What we as TWD designed for them was the gangway itself, but also the big elevator that you can see on the left side of the screen, which they can use to alter the height of the gangway. And in that, there's also an elevator for the personnel to go up to the right location. Then they can walk over the gangway to the you see that they transfer the gangway now to one of the wind turbines. They can transfer people continuously. They can also feed people with the elevator to the gangway, and then they can transfer people, for instance, for maintenance or repairs. That's also a nice way to safely transfer people offshore, which is normally done either by boat landings or more unsafe things and systems. And the nice thing about this is that the workability increases because also during bad weather they can just transfer people to the fixed monopile transition. Then one final thing that I want to show you, it's the piling gate. It's a piling gate that they use to hammer some piles or some walls, some combi walls into the seabed or in a riverbed. It can open up to allow the passing of the hammer through. And we also won a prize with a similar system like this in an English. This was a project of our UK office, and they also won some prizes with it. How does it work? They use some sheet pilings, and then they can hammer it through. The gate can open, and they can reposition that piling tool again. They can again place some piles, and they can open it, and then they can hammer them through. And the nice thing about this is it's a really simple solution, but it saved our clients a lot of time. A similar tool like this was intended also to hammer piles in the river side of the Thames in London. While the contractor was expecting to pile 2 to 4 piles every day, with our tool they installed 4 to 8 piles every day. And you can imagine that cutting the complete time of the project in half really saved them a lot of time and money. So that was a nice feature where we can help our clients with. So that's actually some highlights of the projects that I wanted to show you. We're always looking for some intelligent and creative individuals for some following positions. So we're also always looking for project engineers, designers, but also for commercial, some people, some technical sales engineers, business developers. But I think more important maybe for you as well, we also offer internships, graduation projects. So if you're interested, take a look at our website and please send your letter of motivation and your resume to hr@twd.nl, or you can always contact us via phone. That's concludes my presentation. I'm not sure if there are any questions, but please go ahead.
There's a question from Sue Ellen in the chat.
Yeah.
I will read it. Sue Ellen said in the chat that, how long does it normally take to design a project like a wind turbine?
Well, to be clear, we don't design the wind turbine, but normally it's a long project, so a long trajectory. When the intention is done to design a wind farm, they pick up some location, they get investors in, and they start designing the complete wind turbine, also with the foundation. We're usually brought in 1 or 2 years before they start executing the project. If we have 1 or 2 years, that's really a lot of time, because sometimes it's also 6 months. And then they say, well, we need to have this equipment for installation of that of those wind turbines. So in that case, we start working with them, and usual projects with us take about 3 months to completely design and make calculation reports of these tools that I just showed you. Then the design starts getting into fabrication, and then usually 2 or 3 months after that, they will start installing the wind turbines. So we're really at the end of the stage. Our running time for projects is usually not more than 3 to 6 months. I think for items like a barge master, that of course took some more time. So that took us maybe half a year for each project to complete. I hope that answers your question. I saw another question.
Yes. Okay. Anna asked how deep the piles can be drilled in the sea, and what's the maximum?
Well, that differs a bit. That depends a little bit on the seabed. So what we see is that for some monopiles, they're 60 meters long, and they're installed in water depths of 25 meters. So then you can calculate it's 30 meters of hammering into the seabed. But there are also different lengths. Normally in the North Sea, most of the piles are approximately 60 meters long, and water depths are range from 20 to 30 meters. So yeah, it's 20 to 30 meters that's hammering in the seabed. I can see another question from Luc Hovens about the jobs. Are there also part-time job openings that could be done simultaneously with a master? So they are somewhat flexible in case the study load shifts from one day to another. That's true. We do have some.
Shall I answer it?
Yeah, maybe Charlotte can answer it. She's,
yes, I'm HR organizers. That's why I'm here also to answer questions like that. So basically, we do have the option to do part-time or work as a working student, but usually only after you've done an internship first. And that is because it takes a lot of time to really get trained in what we do. And it's really difficult to do that if you're only there for 2 or 3 days, since projects usually continuously go through every week. Yes, so it is an option, but preferably only once you have already had at least 3 months of an internship.
Okay, thank you, Charlotte. I see another question from Hidde. How big are teams working on a project? It depends. I've done projects where I was the best team is no team, so then I was the only one in the team. But I think for the projects that I've just showed you, those are some pretty big projects, especially the sea fastening projects. They usually take teams up from 20, maybe 30 people. I think those are really big project teams. Most project teams that we have at TWD are from 10 10, 20 people approximately for these sort of projects. But like I said, I've also done projects with 2 or 3 people. I'm now doing some projects for a steel builder, which is close to us, which I'm doing with 2 or 3 people. We always try to make a project team, even when it means that people are only partly working on it, so that we can check ourselves. So you don't want someone cowboying on their own. Yeah. From Milos, positions and responsibilities for structural engineers with limited knowledge in dynamics. It seems like my bio. I'm a structural engineer. I don't have that much knowledge in dynamics, so I don't. So we have all different disciplines. We have a dynamics group, which mainly focus on stuff like the motion compensation systems, but also on motion analysis of vessels that are moving in water, which is much more into the dynamics. The team that I'm working on is much more focused on structural engineering. So we get the loads from the guys from the dynamics group. They say, okay, this is on a vessel and it gets that loads. And then we say, okay, then we calculate, we do the structural design, we make sure that everything is strong enough. And for the software and for the hydraulics and that sort of stuff, we give it back to the dynamics guys, or we outsource it. So there are possibilities for every discipline. Another question, how do you deal with the tolerances of the gripper and the attachments when everything is moving on the scene? Yeah, that's a good question. That's really really hard. So usually tolerances are in the shape of 1 meter or a couple of degrees. What we normally do is make sure that everything is stiff enough to make installation with those tolerances possible. So we either make it fixed to one of the jacket vessels that I've shown, but for the motion compensated gripper, for instance, we have to make sure that the system itself is also stiff enough to keep the monopiles firmly in place. I see another question from Hide. Do you work with FEM tools a lot? Sometimes, when the job asks for it. So we do a lot of hand calculations, really by hand, but also by, of course, our programs, ModCAD, Excel. We use calculation sheets, of course. Sometimes we have to do some more in-depth analysis, and then we use FEM programs. But it's always at the end of the project stage, so to say. So really to do a checkup on something. We don't use FEM to design something because we have the philosophy that everything, the system itself has to be thought of. The concept has to be thought of with hand calculations and Excel calculation and good engineering practice. The FEM, we only use it for real verification. Sometimes also the clients ask for some verification by a FEM analysis because they have some, they want to really see the effects. But the downside of FEM, of course, is also that it can also create a lot of white noise because you can see peak stresses that in reality are not there. I see some other questions popping in. From Tim. For buildings, we have a standard Eurocode to check the safety of the structure. The government will also check the structure based on the standard. What standard uses TWD to design their structures, and which authority checks these calculations and design? It depends. Sometimes we do some civil works, and then it's also checked with Eurocode, and it's also sometimes checked by government or by the client. Most of the codes that we use, the standards that we use are from marine warranty surveyors. societies like DNVGL, Lloyd's Register, they all have these standards which they tested to. So we make a design, it gets checked by the marine warranty surveyor or by the surveyor or by a certifier. They certify it. It's like in Holland you always had the KEMA-keur. They gave a stamp on it saying, okay, we think it's safe. That's also with the DVGL. They gave a stamp on it. They say, okay, we think it's safe, and then the client can get with that stamp. It can get insurance. Usually, authorities are not really involved in that process. It's more like a play between the client, the warranty surveyor or the contract, the certifier, and insurance companies, because they want to, of course, have some guarantee that what we did on that vessel is not going to make it sink. So we have to make sure that everything stays in one piece and that everything is getting done safely, and that people are not injured, for instance. Why is the average the people who work at TWD 30 years? It's a good question. I think we like a really young, enthusiastic group. We do have some older people. I think the oldest employee is 35, who is one of the founders as well. But we also have some older people, and I have to say we get a little bit more older people in. But we also recruit a lot of people from university and from because yeah, the knife cuts a bit on both sides. So on one hand, we get all that new young blood in, where the enthusiastic people, and also with some out of the box ideas that we might not be thinking of anymore. On the other hand, we can still mold them a little bit in the TWD culture. And also in the calculation culture. Yeah, and one other reason is also that yeah, we don't really have that much mechanical and structural engineers. There's a shortage on the market, so it's always nice to get some new young people in.
Well, thanks Marcel for your answers, and thanks for the presentation. Then first, Evelien will, oh yeah, and thanks everybody to be here. First, Evelien will unmute everybody, so we will give you an applause. Everybody is unmuted.
Wait, I'm almost there. Yeah.
Well, normally we have at the end we have a small gift. So the small gift and a bottle of wine is going to TWD. So maybe you already have it, but
no, it will arrive tomorrow morning.
Okay. Tomorrow I'm working from home again, so that I will receive it, but that nobody else will run away with it.
And thanks everybody from KOers for being here. And for our upcoming events, check the website. So next week we will have a lecture from Continu about online solliciteren. And on the 14th we will have a lecture from Van Rossum about Sluishuis, and a very interesting project from Van Rossum. So thank you everybody for being here.
Yes, thank you for your attention.
Have a good day.
Yes, thank you. Okay.